In this video, we are going to see Laplace transform properties, and based on the properties, we are going to see some problems. So first, let us recall the properties. First property is linearity property. So according to linearity property, if we take Laplace transform of x of t, you will be getting capital X of s. Laplace transform of y of t, y of s. Then according to linearity property, we can write a into x of t plus b into y of t. On taking Laplace transform, we will be getting a into x of s plus b into y of s. Next property is time shifting property. So here we will be shifting the time in the time domain. So this is time domain and this is the frequency domain. So if x of t on Laplace transform, x of s means, then according to time shifting property, we can write x of t minus t naught on taking Laplace transform e power minus s t naught into capital X of s. The next property is frequency shifting property. So here also, if x of t on Laplace transform x of s, then according to frequency shifting property, here the shifting is done in the frequency domain, right? So e power s naught into t into x of t on taking Laplace transform, we will be getting capital X of s minus s naught. The next property is time reversal property. So if x of t on Laplace transform x of s, then according to time reversal property, x of minus t on Laplace transform, we will be getting capital X of minus s. The next property is time scaling property. So if x of t on Laplace transform capital X of s, then according to time scaling property, x of at on Laplace transform 1 divided by mod a into capital X of s divided by a. So these properties are similar to the Fourier transform, but here we are using it in the s domain. The next property is differentiation in frequency. So here also, x of t on Laplace transform capital X of s, then minus t power n into x1 of t on taking Laplace transform d power n into x1 of s divided by ds power n. So if n is equal to 1 means you will be getting minus t into x1 of t on Laplace transform dx1 of s divided by ds. Like that it goes on. Multiplication property. So if x of t on Laplace transform capital X of s and y of t and Laplace transform y of s, then according to multiplication property, x of t into y of t on Laplace transform, you will be getting 1 by 2 pi j x of s convolution with y of s. Convolution property. In convolution property, if x of t on Laplace transform x of s and y of t on Laplace transform y of s, then according to convolution property, convolution of two signals in the time domain is equivalent to multiplication of two signals in the frequency domain. So x of t convolution with y of t on Laplace transform, you will be getting x of s into y of s. So these are the important properties of Laplace transform. So first problem, determine the unilateral Laplace transform of the signal x of t is equal to u of t minus 4. Now we have to find the Laplace transform. So either we can apply the formula directly, otherwise we can use the properties. So u of t minus 4. So u of t minus 4 means first we have to draw the graph for this. So u of t means unit step function. So t minus 4. So t minus 4 is equal to 0. So t is equal to 4. So you will be getting the graph from 4. So the limit changes from 4 to infinity. So if you want to replace u of t minus 4 by 1 means we have to change the limit from 4 to infinity. So e power minus st divided by minus s, then we have to apply the limit 4 to infinity. So that is equal to e power minus 4s divided by s. Now by using shifting property, that is time shifting property, we are going to solve this problem. So according to time shifting property, u of t minus t naught on Laplace transform, you will be getting e power minus s t naught into capital X of s. So Laplace transform of u of t, already we have seen Laplace transform of u of t is 1 by s. So that is X of s. So u of t minus 4 is equal to e power minus 4s divided by s. So instead of t naught, we have to substitute this 4. So e power minus s4 divided by s, this 1 by s. So this is the answer. Next problem, x of t equal to t into e power minus 4t. So here we are going to use the differentiation in frequency property. So according to differentiation in frequency, minus t power n into x1 of t on Laplace transform, you will be getting d power n into x1 of s divided by ds power n. So here according to our problem, n is equal to 1 and x1 of t equal to e power minus 4t. So minus t into x1 of t on Laplace transform, we will be getting dx1 of s divided by ds. So in this problem, since there is no negative sign, we have to move this negative sign to the right hand side. So t into x1 of t on Laplace transform will be getting minus d into x1 of s divided by ds. So x1 of s is equal to integral 0 to infinity x1 of t e power minus st into dt. So that is equal to e power minus 4t into e power minus st into dt. On simplifying this, and we have to apply the limit 0 to infinity. So you will be getting the answer as 1 by s plus 4. That is equal to s plus 4 the whole power minus 1. Now we have to differentiate it. So minus 1 into s plus 4 the power minus 2. So that is equal to minus 1 divided by s plus 4 the whole square. Now the Laplace transform of t into e power minus 4t is equal to, already we are having a minus sign in the differentiation. So that minus and this minus converted to plus. So the answer is 1 divided by s plus 4 the whole square. Next problem, x of t is equal to e power minus at into cos omega 1t. So here we are going to use frequency shifting property. So already we have seen the property as x1 of s minus s naught is e power at into x1 of t. So here we are having s plus a. If you are having s plus a means here you have to change the sign of the power, that is e power minus at. If you are having s minus a means we have to put e power plus at. So now x1 of t is equal to cos omega 1t. So Laplace transform of cos omega 1t equal to x1 of s. So that is equal to s divided by s square plus omega 1 square. Already we have calculated the Laplace transform for this cos omega 1t. So x1 of s plus a is equal to, here instead of s replaced by s plus a divided by s plus a the whole square plus omega 1 square. So Laplace transform of e power minus at x1 of t is s plus a divided by s plus a the whole square plus omega 1 square. Similarly, the next problem, x of t equal to e power at into sin omega 1t. So there cos omega 1t, here sin omega 1t. Here also we are going to use the frequency shifting property. E power minus at x1 of t on Laplace transform, you will be getting x1 of s plus a. So x1 of t is sin omega 1t. If we take Laplace transform of sin omega 1t is equal to omega 1 divided by s square plus omega 1 square. Now we have to apply. Laplace transform of e power minus at into x1 of t is x1 of s plus a. Here instead of s you have to substitute s plus a. So omega 1 divided by s plus a the whole square plus omega 1 square. The next problem, x of t equal to t square sin t. So here also we are going to use the differentiation property. But here we are going to assume n is equal to 2. So t square x1 of t on Laplace transform d square x1 of s divided by ds square. So x1 of t is equal to sin t. x1 of s is 1 divided by s square plus 1. That is, normally what is the formula for sin omega t? Laplace transform of sin omega t is omega divided by s square plus omega square. So here omega value is equal to 1. So you will be getting the answer as 1 divided by s square plus 1 square. So that is equal to s square plus 1 the whole power minus 1. So here we have to differentiate it 2 times since it is d square. So first time differentiation you will be getting minus 2s divided by s square plus 1 the whole square. On second time differentiation you will be getting minus 2 into s square plus 1 the whole square plus 8 s square into s square plus 1 divided by s square plus 1 the whole power 4. So that is equal to minus 2 into s square plus 1 plus 8 s square divided by s square plus 1 the whole cube. So Laplace transform of t square sin t is equal to, on simplifying this, you will be getting 6s square minus 2 divided by s square plus 1 the whole cube.